To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.
Hello my dear students, welcome to today's lesson. So I'm going to continue with the extra questions related to the 10th lesson, that is household electric circuits or domestic electric circuits. So in the previous chapter also I discussed some extra questions with you all. So I'm sure you will answer these questions first and then you will listen to my discussion and compare your answer with my answer. So in the lesson, you all can remember students, we discussed the different energy conversions taking place in electrical appliances. Thereafter, we discussed power and energy of electrical appliances and the efficiency of different electrical appliances when it comes to a certain purpose. For example, if you take the light bulbs, there are different types of light bulbs and we compare their efficiencies based on lifetime and the electricity consumption. And thereafter, we discuss the components of a household electric circuit starting from the supply cable until the different sockets, that is the plug sockets and the switches connected to the circuit. So you all know the components and the functions of those components. And finally, we learn to calculate the number of units of electricity consumed by the consumer. That is calculated in kilowatt hours. So that was what was discussed in the lesson. So now the extra questions related to the lesson. Extra question 4. First one, an electric device operates under 200 volt power supply, that is the voltage or the potential difference. If it has a power output of 100 watts, find the current drawn when the device is working. So here you have the voltage, that is 200 volts and the power 100 watts. You need to find the current. So what is the relationship? You know the equation, power equals voltage into current. That is P equals VI. You all know what power is. Power is the work done in a unit time or the electric energy consumed in a unit time. That is calculated by multiplying voltage into current. So you can only write this equation, students. You don't have to write both. You don't have to write it in words and in symbols. Here, for you all to remember the equation, I am writing both. So in this also you need to find current. So we have to either rearrange the equation and substitute, or you can substitute and rearrange. We need to find current. So I am going to rearrange. So here I is the subject of the equation. So then power divided by voltage. So that is equal to, power is given to you all 100 watts. And the voltage potential difference 200 volts. So 100 divided by 200, that is going to be 0.5 and current amperes. So that is the answer. An electric device operates under 200 volt power supply. If it has a power output of 100 watts, find the current drawn when the device is working. So voltage is given 200 volts, power is 100 watts. So power equals V into I. I is equal to power divided by V. So that is 100 watts divided by 200 volts. 0.5 ampere current is drawn by the device. I am sure you also have calculated it correctly. So with that, I am going to move on to the next slide. Extra question 5. Write the equation for the energy consumed by an electric appliance. Now you all can remember, power is the energy consumed in a unit time. So the power of a particular electric appliance into time that it operates gives you the energy. So energy E equals power into time, P into I. But their power has to be in watts and time has to be in seconds, so that you get the unit of energy in joules. You have to remember that. So write the equation for the energy consumed by an electric appliance. So energy equals power into time. So if you write it in symbols, E equals P into T. But you all know this is one equation, you can use this. Otherwise, we can substitute for power as well. Power is equal to what? Volt into current, voltage into current. So because of that, you can write the equation as E equals voltage current into time. So either E equals power into time PT or E equals VIT, voltage current into time. So you can write both equations. Write the equation for the energy consumed by an electrical appliance. Energy equals power into time, that is E equals P into T. Otherwise, E equals V into I into T, VIT. Both are correct. So then, now another thing students, you all have to remember, now here they have just said write the equation for energy. Now if they specifically say write the equation for energy based on the power of the appliance, then you only write the first one. Or if they say write the relationship or write the equation for energy related to the potential difference and current, then you have to write this. But here, since it's not mentioned, I have written both the answers, both the equations. Both are correct, but depending on the question, you might have to select and write. So then, the second question. What is the electrical energy consumed by a device that draws a current of 0.5 amperes for 2 minutes across a voltage difference of 6 volts? So here you know what equation to use. You have to use this one. Energy equals VIT. And here when we substitute voltage difference 6 volts, that is 5. Current 0.5 amperes, that is also correct, the correct units. But time, you can see it is 2 minutes. But here the time has to be in seconds so that you get the energy in joules. So what do you need to do? Minutes to seconds, you need to multiply by 60. So 2 into 60 seconds. So then it is going to be 6 into 0.5 into 120 joules. That is going to be 360 joules. 6 into 0.5, 3 into 120, 360 joules. That is the energy, electrical energy consumed by a device that draws a current of 0.5 amperes for 2 minutes across a voltage difference of 6 volts. So E equals VIT, 6 volts into 0.5 amperes, and the time has to be in seconds, 2 into 60 seconds. So when you calculate, you get the answer as 360 joules. So with that, I'll move on to the next question. Extra question 6. Power of an electrical equipment is the work done in a unit time. So that is what we have defined power as. Power is the work done in a unit time. Or else electrical energy consumed in a unit time is also power. Then the first one, write a relationship between power, voltage and current. So what is the relationship? Power equals voltage into current. That is the relationship, power, voltage and current. or P equals VI. That is the equation. This is the relationship. When you write it in words, you give the relationship. Power equals voltage into current. Then, power of a filament bulb is 24 watts. Power of a filament bulb is 24 watts. Calculate the current flow through the bulb when a potential difference of 12 volt is supplied across it. So, you need to calculate the current flow. Then, what is the equation? Same equation, power equals volts into voltage into current. Power equals voltage into current. So, you need to find the current. Again, you can substitute and rearrange or rearrange and substitute. Here, I'll substitute first. 24 watts power, voltage is given as 12 volts and current is I. So, if you rearrange, I is equal to 24 divided by 12. That is equal to 2 amperes. The unit will be in amperes. So, power equals voltage into current. Power is given to you as 24 watts. Voltage is given as 12 volts. And then current I. When you rearrange, I is equal to 24 divided by 12. That is equal to 2 amperes. I am sure you can understand that. So, with that, I'll move on to the next question. Extra question 7. In some appliances, part of the electric energy is converted into heat. So, you know that. Say in a filament bulb or a radio, television, a part of the electric energy is converted to heat. Why is that? There is internal resistance in that particular electrical appliance. So, because of that, a part of the electricity is used up against that internal resistance and it is converted to heat. So, you all know why this happens. Explain the above statement briefly. So, that is what you need to do. You need to explain the above statement. So, how do we explain this? You can say, some appliances have internal resistance. Part of the electricity consumed is converted to heat due to this internal resistance. That is what you need to write. Some appliances have internal resistance. Part of the electricity consumed is converted to heat due to this internal resistance. So, you are supposed to explain, in some appliances, part of the electric energy is converted to heat. So, that is the explanation. Then, second part, write 3 electrical appliances that convert electricity to heat. Now, in the previous question, there are appliances where you need to produce a different type of energy other than heat, but still heat is being produced. But here, these are appliances where electricity is converted to heat. So, electrical appliances that convert electricity to heat. Can you think of some? An electrical iron, electric iron. Immersion heater, electric iron used to iron clothes. Immersion heater to boil water. Then you have the rice cooker, which uses an electric coil. So, that is a rice cooker or a hot plate. Then there is the induction cooker. the electric oven. In all these electrical appliances, electricity needs to be converted to heat. So you only need to write 3 electrical appliances. So I can write electric iron, then immersion heater, and rice cooker. You can also write electric oven, then you can write hot plate, you can even write electric kettle, all those devices, induction cookers, all these devices, we need to convert electricity to heat energy. So based on the usage, based on their requirement, electricity is converted to heat. In electric iron, immersion heat and rice cooker. In addition to that, hot plate, electric kettle, then you have the induction cooker, electric oven. In all those, heat is produced. So you can write any of those electrical appliances. So with that, students, we'll move on to the next question. Extra question 8. A few different types of bulbs giving the same illumination, their power output and lifetimes are given in the table below. So here you have a table. In that they have given the power output and the lifetimes. So here the first column gives you the light source, then the power and the lifetime. So light source filament bulb, power is 60 watts and the lifetime is 1200 hours. Then fluorescent tubes, 22 watts power consumption, 3000 hour lifetime. CFL bulb, compact fluorescent lamps, that is the CFL bulb, 11 to 13 watt power and 8000 hours lifetime. Then LED lights, 6 to 8 watts and 50,000 hours lifetime. So if you look at all these, you can understand the filament bulb has the highest power consumption, 60 watts, whereas LED 6 to 8 watts only. So as you go down, the power consumption decreases. And also look at the lifetime. Filament bulb only 1200 hours, LED lights 50,000 hours. So the lifetime increases. So from that, what can you understand? Filament bulb is the least efficient bulb. Why? More power consumption, less lifetime. But LED lights have very less power consumption comparatively and they have very high lifetime. So LED is the most efficient light bulb and filament bulb is the least efficient light bulb. That is the information you can get from this particular table. So then, to answer the questions, first one, what is the most efficient light bulb? So like I said, it is the LED lights. LED lights. Second one, what is the limitation of the use of the bulb you mentioned above in Sri Lanka? Now in our country, what is the limitation? Now if you compare all 4 bulbs, the filament bulbs are comparatively cheaper than a LED bulb. Now when a person needs to buy a bulb, they normally look at the price as well. But if you really compare, now compare the lifetime. 1200 hours for filament bulb, 50,000 hours for LED bulb. So with the long-term usage, if you consider, the high cost of LED is reasonable because it consumes very less power and also it has a very long lifetime. You don't have to change the LED bulb very frequently. Whereas filament bulbs, it's cheaper to buy initially. But the electricity consumption is high and the lifetime is very less. But still, because of the high initial cost, there is a limitation of the use of LED bulbs in Sri Lanka. So that is what you need to write here. What is the limitation? So you have to say LED bulbs or LED lights have high initial cost. So that is the reason why the usage is limited. LED lights have high initial cost. So I am sure you can understand that, students. So we compared the different types of bulbs, and you all know filament bulbs are the least efficient and the LED lights are the most efficient. But there is a limitation because their initial cost is high. That is what you need to understand. So with that, students, I will move on to the next slide. Extra question 9. What is the most efficient electric appliance that can be used to boil water? So there are different electric appliances that are used to boil water. You can just use an electric cooker, a hot plate, then you can use an immersion heater or even an electric kettle. Out of all these, the immersion heater is the most efficient one. Why is that? Because when you use an immersion heater, you all can remember that, students. I will show this diagram just for you all to recall what we have learned. Now, this is the vessel containing water, what we do is we have the immersion heater. So here it's connected to the wire, and here we have the heating coil. So this heating coil is immersed into water. And if you bring it right to the bottom and touch the bottom surface of the vessel, it is even more efficient. Because by conduction, heat is given from bottom to top inside water, and all the heat that is produced by the heater is transferred to water. There is no heat loss. So that is why the immersion heater is the most efficient one. So what is the most efficient electric appliance that can be used to boil water? Immersion heater. Immersion heater. So here, of course, students, you don't have to draw the diagram. I have drawn it, so just for you all to recall what happens there. But the answer is immersion heater. And why? Because all the heat generated by the immersion heater is transferred to water. So because of that, there is no heat loss. It is very, very efficient. So the most efficient one is immersion heater to boil water, because all the heat generated by the immersion heater is transferred to water. In other methods, there is a loss of heat to the environment while it is being transferred to water. But here, since the immersion heater is inside water, it's in the middle, all the heat is given to water only. Heat is transferred only to water. I'm sure you all can remember that. So with that, we'll move on to the next question. Extra question 10. Electric energy required to operate home electric appliances is obtained from the national electric grid. That you all know. The power plants generate electricity and that is supplied to the national grid. From there, electricity is transported or transferred to the distribution sub-centers, and from there we get electricity to the household. So basically it is the national electric grid that supplies electricity. What type of current is supplied to the household? So initially it is the power plant where the electricity is generated, and from there the electricity is supplied to the national electric grid. there the voltage becomes 132 kilovolts or 220 kilovolts. The voltage is increased using the step-up transformer. But then from the sub-centers where the electricity is supplied to households, there again the potential is reduced using a step-down transformer. There, of course, the potential is reduced to about 11,000 volts. And before electricity is supplied to the household, using the distribution wires, the potential difference is decreased to 230 volts. And you all can remember, the electricity supplied to the household, it is an alternating current, AC current, and it has a frequency of 50 Hertz, and usually the current is about 40 amperes. So it is an alternating current AC with a frequency of 50 Hertz and voltage of 230 volts, and current is the maximum that can enter into the household is 40 amperes. Because you all know the overload circuit breaker does not allow current more than 40 amperes. So those are information that you all have to remember, students. So what type of current is supplied to the household? It is alternating current. So here we can say AC or alternate current. Alternate current. AC current or alternate current. Then the second question, what is the voltage of current supplied to the household? Like I said, it is 230 volts. Voltage is 230 volts. And what is the frequency of current supplied to the household? It is 50 Hertz. 50 Hertz. So these are the values you all have to remember, students. From the distribution wire to the supply cable into the overload circuit breaker. So it is AC alternating current with a frequency of 50 Hertz. And the voltage is 230 volts. And the maximum current that can flow through the overload circuit breaker or the service fuse is 40 amperes. You all have to know all these values, students. So with that, we'll move on to the next question. Extra question 11. Part of the domestic electric circuit is shown in the diagram below. So here you can see the some of the components that is part of the domestic electric circuit. Can you identify the component? First look at the diagram. So here you can see L denotes the live wire, N denotes the neutral wire. Then we have component A. What do you think that is? Connected only to the live wire. The first component. The overload circuit breaker or the service fuse. That is connected only to the live wire. And then we have B, you can identify it is the electricity meter. And you all know both A and B belong to the service provider. So then, we have the other components. From the electricity meter, you can see live and neutral wires. Both are connected to component C. What is that? It is the isolator. Isolator is the main switch with the main fuse. Now, through the overload circuit breaker, it is about 40 ampere current, maximum 40 ampere current. Then here it is maximum 30 ampere current. And you can see both live and neutral wires are connected. So that means it is a dual pole switch. You can remember that. Then from there, again live and neutral wires, both are connected to component D. And here also you can see it is a dual pole switch. What is it? It is the RCCB, residual current circuit breaker, or the trip switch, that is component T. Then from there, live wire is connected to this. This is the bar, the bus bar that supplies current to the different MCBs, miniature circuit breakers. So all those components, and here you can see the neutral wires are connected there. So both live and neutral wires with the MCBs, they are present in a distribution box. So E is a distribution box. So you have identified all the components. What is A? It is the service fuse or the overload circuit breaker. Then B is the electricity meter. C is the isolator, that is the main switch with the main fuse. And D is the RCCB, residual current circuit breaker or the trip switch, and here E is the distribution box. Now in modern electric circuits, all these three, C, D and E, they are present inside the consumer unit. But in the old households, the distribution box is separate from the trip switch and the main switch. You can remember that. So that is how we have the components. Now let's look at the questions. First one, write the two wires present in the service cable that supplies electricity to the household. So the service cable has these two wires, the live wire and the neutral wire. So it is the live wire and the neutral wire. Live wire and the neutral wire. Then we have the second question. Identify the components A to E in the diagram. We have already identified them. You have to answer them here. You have to write them down here. What is A? Overload circuit breaker. Overload circuit breaker. Or another name, it is the service fuse. I am going to write only one name here, but you have to remember the other names as well. Overload circuit breaker or the service fuse. Then what is B? Electricity meter. Electricity meter. Electric meter or electricity meter that tracks or that actually has a record. It has that rotator which measures the number of units. So there you can read the number of units of electricity consumed by the consumer. Then C. C is what? C is the isolator. So here I will write it as isolator. You can remember it is the main fuse with the main switch, or you can say main switch with the main fuse. Basically it contains both the main switch and the main fuse. Then D. D is the trip switch or the RCCB. So here we can say RCCB or trip switch. RCCB means residual current circuit breaker. You can write that also, residual current circuit breaker. Then we have component E. E is the distribution box. Inside the distribution box only you get the MCBs, miniature circuit breakers, but the full component E is the distribution box. So E is the distribution box. Distribution box. So here you can see overload circuit breaker A, electricity meter B, isolator C, then residual current circuit breaker RCCB or trip switch D, and distribution box E. Those are the components. Then the next question. Write the functions of the components mentioned above. First one is A. A, overload circuit breaker. Circuit breaker or what you can call as service fuse. What is the function of this overload circuit breaker? If there is a current more than 40 amperes flowing into the household circuit, this will disconnect the electricity supply to the whole household. So it prevents the electrical appliances from getting damaged due to high current, or else it prevents accidents caused by high current. So it basically doesn't allow current more than 40 amperes to flow into the household. So that is the function. You can say it disconnects the electricity supply to the whole household if a current more than 40 amperes flows through it. So that is the function of the overload circuit breaker. Then the next one, B, you all can see it is the electricity meter. B is the electricity meter. What does the electricity meter do? It records the amount of electricity consumed by the consumer as kilowatt hours. And say records, or we can say measures. It's basically there is a keeping track of the amount of electricity. Records the amount of electric energy consumed by the household in kilowatt hours. The commercial unit of measuring electric energy is kilowatt hours. It records the amount of electric energy consumed by the household in kilowatt hours. Then after the electricity meter, what do we have? Component C. Component C is what? It is the isolator. Isolator or main switch with main fuse. So what does the main switch with main fuse do? You can use the main switch to manually disconnect the electricity supply to the household. That is possible. Otherwise, there is the main fuse. So if there is a current flow of over 30 amperes into the household circuit, then the isolator automatically disconnects the electricity supply to the whole household. So this acts as a high current fuse. High current fuse, because the main fuse, high current circuit breaker. So it cuts off the electricity supply to the household. So that is the function of the isolator. So here we can see, if there is a current flow more than 30 amperes, the isolator disconnects the electricity supply to the whole household. So it acts as a high current circuit breaker. High current circuit breaker. What is the second function? Main switch is used to manually disconnect the power supply, electricity supply to the household. So here main switch is used to manually disconnect the electricity supply to the household when required. Now, if there is a huge repair work going, if you want to change the electricity cables or connect a new line, connect a new plug socket, or else if there is some repair, or else if you are going out of the house for a long period of time, say about 2-3 months, and the house has to be closed for that period of time, there is no point having the electricity supply. So you might want to turn off the electricity supply so that you can prevent accidents also. So in that instance, you can use the main switch. You can turn off using the overload circuit breaker or even the trip switch, but the most common one, the function, the purpose of the main switch is again to turn on and off the electricity supply. And you all know the first two, that is the overload circuit breaker as well as the electricity meter, they belong to the service provider. So we don't normally use that to turn off the electricity supply. Instead, this belongs to the consumer. That is, the isolator belongs to the consumer. So in that, there is the main switch that can be used to turn off disconnect the electricity supply to the household. So those are two functions of the isolator. You can remember that. Then after the isolator, what do we have? We have the RCCB. Then that is, this is C, then we have D. D, residual current circuit breaker, that is RCCB or trip switch. What does the trip switch do? Now, you all know in the modern electric appliances, of course, the cover casing is insulated. But in the earlier ones, usually there is a metal covering or a metal casing. So what happens is there is a possibility of electricity leakage to the metal casing. So then the person who is using it can get electrocuted. To prevent that, what happens is there is a wire connection from the metal casing to the earth wire, and there is a wire connected to the trip switch. So if there is an electricity leakage and if that flows through that particular wire, then what will happen is, by electromagnetic induction, there will be a current flow through the trip switch. And because of that, immediately the trip switch disconnects the electricity supply to the whole household. So that is how the RCCB or the trip switch prevents the consumer from electric shock. So that is the function of a residual current circuit breaker. So then, here we can say, if there is electricity leakage or earthing of current then the RCCB disconnects the electricity supply to the whole household and protects the residents from electric shock. Residents from electric shock. And you all have to remember, students, you don't have to write that down here, but you can remember sometimes the trip switch disconnects electricity supply when there is lightning. But it does not ensure the protection from lightning. You have to remember that. It does not ensure protection from or against lightning. That you have to remember. Only against electricity leakage or earthing of current when electricity passes through a person or it gets earthed normally, then automatically the trip switch or the RCCB, residual current circuit breaker, disconnect the electricity supply to the household. You can remember that. That is the function of RCCB. Then we have component E. You can remember component E is the distribution box containing the miniature circuit breakers. Can you see there? It is the distribution box. So now we need to write the function of the distribution box. Distribution box, that is component E. What does the distribution box do? Now the live wires are connected to the bus bar, and from there are different live wire connections going to different parts of the household. So there is a miniature circuit breaker, MCB, for each part of that household circuit. So if there is a high current passing through a particular part of the circuit, it will disconnect the electricity supply only to that part of the household. Say for example, if there is a lamp circuit where is a light bulb connected to it, the maximum current can be 6 amperes. But if there is 7 or 10 amperes flowing through that, then immediately the electricity supply to that particular area will be disconnected. Another example you can think in the kitchen. If there are many plug points, because there are plug sockets where you use different electrical appliances, the maximum current is 13 amperes. So by chance, if there is a current more than 13 amperes flowing into one of the electrical appliance, immediately the MCB relevant to that part of the house, that is the kitchen area, will disconnect the electricity supply only to that area. That is the kitchen area. So that is the function of a distribution box containing MCBs. So E is distribution box containing miniature circuit breakers. Miniature circuit breakers. That is MCB. So just for your knowledge, just for you all to recall, I will write this also. MCB for plug circuit. What is the current? It is 13 amperes. And MCB for lamp or light circuit is 6 amperes. You have to remember that. So if we write the function briefly, we can say electricity is distributed to different parts of the household through the plug circuit and lamp or light circuit. So I have already given you all the information. Plug circuit maximum current 13 amperes, lamp circuit maximum current 6 amperes. But you all know in the lamp circuit, light bulbs and 2 plug sockets with the current consumption of 6 amperes can be connected. But to the plug circuit, it is only the plug sockets that can be connected. You all can remember that. So here basically the distribution box, electricity is distributed to different parts of the household through the plug circuit and lamp or light circuit. I'm sure you all can understand that. So here students, we have written all the functions of all the 5 components present in that circuit. So if I quickly go back to the question. So here you can remember the wires present in the service cable, live wire and neutral wire. Then we saw the diagram. These are the components. We identified them. A as the overload circuit breaker or the service fuse. Then B electricity meter, C isolator, D RCCB or trip switch, and E is the distribution box. Then we wrote the functions of all these components. A overload circuit breaker or service fuse, it disconnects the electricity supply to the household if a current more than 40 ampere flows through it. Then B is the electricity meter, records the amount of electric energy consumed by the household in kilowatt hours. So here C is the isolator or the main switch with main fuse. If there is a current flow more than 30 amperes, the isolator disconnects the electricity supply to the whole household. It acts as a high current circuit breaker. And also, you can use the main switch. The main switch is used to manually disconnect the electricity supply to the household when required. And then we have D, that is the residual current circuit breaker, RCCB or trip switch. If there is electricity leakage or earthing of current, then the RCCB disconnects the electricity supply to the whole household and protects the residents from electric shock. And finally, it is the component E, that is the distribution box, containing miniature circuit breakers, MCBs. MCB for plug circuit is 13 amperes and MCB for lamp circuit is 6 amperes. Electricity is distributed to different parts of the household through the plug circuit and lamp or light circuit. So those are the functions of the different components shown in the diagram. I am sure students, you also wrote a similar answer. With that, I'll move on to the next slide. So here the question continues. Part 4, the same diagram is given to us. We already identified the components. So the fourth one, what is the function of a miniature circuit breaker? What is the function of a miniature circuit breaker? Again, this also disconnects the electricity supply to part of the household where there is a higher current, either more than 6 amperes if it is the lamp circuit or more than 13 amperes if it is the plug circuit flows through it. So basically the miniature circuit breaker prevents overheating of supply cables. Distribution wires or supply cables, the conducting wires, if they get overheated, if there is too much of current flowing, there can be overheating of the wires, and because of that, the electricity circuit can catch fire. So that is prevented by the miniature circuit breaker. So that is what you need to write here. So here you can say MCB disconnects electricity supply to part of the household when current greater than the fuse value passes through it. So you know, plug 13 amperes, lamp 6 amperes. So through the plug circuit, if it is more than 13 amperes, electricity will be disconnected. Through the lamp circuit, if it is more than 6 amperes, electricity will be disconnected. But you have to remember, it is only to the part of the household, not to the whole household. So that is the function of a miniature circuit breaker. So prevents heating of wires. That also we can include. So I will write it here, students. So MCB prevents overheating of conducting wires therefore prevents fire caused by heated cables. If you want, you can include that as well. So this is again, I have given the function, but by doing that, this is what happens. It prevents overheating of conducting wires, therefore prevents fire caused by heated cables. So that is a precaution, a component used for precaution, right? Then the fifth part of the question, what is the wire connected to the circuit breakers or fuses? Always it is the live wire that is connected to the circuit breakers or fuses. You can see here a overload circuit breaker that is connected to the live wire. Then here you can see in the isolator main switch with the main fuse. Here you can see the main fuse is connected to the live wire. But the main switch can disconnect both the live and the neutral wires. That is different. That is a dual pole switch. Even the RCCB is a dual pole switch. But the fuses or MCBs, circuit breakers, they are connected to the live wire. Here also you can see, students, in the distribution box, all the miniature circuit breakers. They are again fuses. They are all connected to the live wire only. This part is the neutral wire. Here you can see clearly this part is the live wire. All the fuses are connected to the live wire. There is no fuse connected to the neutral wire. So always it is the live wire. This component, here you can see this component to the live wire, and here also the fuses are connected to the live wire. Always circuit breakers or fuses are connected to the live wire because electricity flows into the household or the electrical appliance through the live wire. It flows out through the neutral wire. So the fuse has to be connected to the live wire. So I'm sure you all can remember that. So here, what is the wire connected to the circuit breakers or fuses? Live wire. Then the sixth one, what is a consumer unit? Now in the modern household circuits, the distribution box, the trip switch and the isolator all are present together in a consumer unit. So here we can say a unit used in modern household circuits that consist of the isolator, RCCB, and the distribution box. So all together, distribution box means the miniature circuit breakers present inside the distribution box, RCCB the trip switch, as well as the isolator, main switch with the main fuse. All those together is present inside the same unit, that is the consumer unit. I'm sure you all can remember that. We saw it in the lab also. So with that, students, I'll move on to the next question. Extra question 12. Electric energy required to operate home electric appliances is obtained from the national electric grid. There are many components in the household electric circuit. You all can remember that. Electric energy required to operate home electric appliances is obtained from the national electric grid, and there are many components in the household electric circuit. Write the functions of the components given below. So you need to write the functions of these components: trip switch, distribution box, and electricity meter. So now we will write down the functions. What is the function of a trip switch? You all know the trip switch disconnects power supply when there is an electricity leakage or earthing of current. So therefore, it protects the residents or the consumers from electrocution. That is the function of a trip switch. So here we can say connects electricity supply to the whole household when there is electricity leakage or earthing of current. Then, distribution box. It contains the miniature circuit breakers and it distributes current or electricity to different parts of the household. So, distribution box distributes electricity to different parts of the house through the lamp circuit and the plug circuit. So, in the previous question also, students, we discussed the functions of these components in detail. So, here I am writing the function more briefly. Distribution box distributes electricity to different parts of the house through the lamp circuit and the plug circuit. And you all can remember there are the miniature circuit breakers or the fuses which control the amount of maximum current that can flow through the circuit. So you can remember the function. Then the electricity meter. What is the function of the electricity meter? Amount of electric energy consumed by the consumer is recorded in the electricity meter or monitored by the electricity meter. We can say it monitors the amount of electric energy consumed by the household in kilowatt hours. You know the commercial unit as well. Electricity meter monitors the amount of electric energy consumed by the household in kilowatt hours. 1 kilowatt hour is equal to 1 commercial unit. I'm sure you all can remember that. So these are the functions of the different components. So this is a question where you are supposed to write the functions of the components given below. Trip switch disconnects electricity supply to the whole household when there is electricity leakage or earthing of current. Then distribution box distributes electricity to the different parts of the house through the lamp circuit and the plug circuit. An electricity meter, it monitors the amount of electric energy consumed by the household in kilowatt hours. So I'm sure students, you all also wrote the correct function for each of the components. So okay students, so those are the functions of different household circuits. Then I will end this chapter at this point and I will continue with some more extra questions in the next chapter as well.
To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.